A linear equation in one variable is an equation that can be written in the form ax plus b equals 0, in which a and b are constants, with a not equaling 0. Look at the examples below. Are each of these linear equations? Looking at the first example, we see that if we would use the addition principle and subtract 9 from each side of the equation, it would result in the equivalent equation x minus 2 equals 0, which we see is in the form written above. Therefore, that is a linear equation. Examples 2 and 3, if we use the addition principle, would also result in the same form as is listed above. Our next two examples may require a few more steps, but ultimately they also are examples of linear equations because they could be written in the form ax plus b equals 0. Our last two examples, however, x squared equals 9, is not a linear equation, nor is the absolute value of x plus 1 equal 0 a linear equation, because each one of these cannot be written in the form listed above. For our first 5 examples, which are all linear equations, we use the same equation solving process for all of them. And this is the process. Our steps to solving linear equations in one variable require us to first simplify each side of the equation, and then second, we use the addition and multiplication properties of equality to isolate the variable term, and then we isolate the variable. Let's do 4 examples together. Example 1, we first look to see if we can simplify each side of the equation, but each side of the equation is already simplified. Therefore, we begin by isolating our variable term of 5x, and to do that, we subtract 9 on each side. This means that 9 minus 9 equals 0, and we get 5x equals 15. Now that our variable term is isolated, we can try to isolate the variable by using the multiplication property. Our equivalent equation is x equals 3, and therefore 3 is our solution. Example 2 is similar. We first look to simplify each side of the equation, and there's nothing more to be done. So now we move straight to the addition and multiplication properties of equality. We will isolate our variable term by subtracting 13 from each side, resulting in the equation negative n equals 54. And our n is still not isolated until we use the multiplication property and divide each side of the equation by negative 1. Therefore, n will equal negative 54, and we see clearly that negative 54 is our solution. Steps 3 and 4 do include that first step of simplifying each side of the equation. In example 3, we must first begin by distributing our 2 to the quantity x minus 8. Once doing that, we will get 2x minus 16 equals 10. And now we again use the addition property to isolate our variable term. 2x equals 26. And then we use our multiplication property to divide by 2. So x equals 13. And 13 is our solution. Finally, in step 4, our first step when simplifying each side of the equation is to combine our like terms. X plus 3x can be combined to make 4x. We carry down the rest of our equation and then isolate our variable term. And then isolate our variable by dividing by 4. So x equals 23 over 2, which is a negative 23 over 2, once we simplify it. And we see that our improper fraction of negative 23 over 2 is in fact our solution. Looking at two more examples together, these next two examples have like terms that are on opposite side of the equal sign. Let's see what we do in these situations. Step one, we begin by trying to simplify each side of the equation, but there's nothing more to be done on each side of the equation. So now we try to use the addition and multiplication properties. We want to combine our 5n and our 2n, but since they are on opposite sides of the equal sign, we have to use the addition property to do so. I'll begin by subtracting 2n from both sides of my equation. Doing this will allow me to combine those like terms and get the equivalent equation 3n plus 4 equals 13. Now we are in a similar process and type of equation that we saw on the last page. We'll subtract 4 to isolate our variable term, 3n equals 9, and divide by 3 using the multiplication property to get n equals 3. And so 3 is our solution. The equation on the right involves a few more steps, but a similar process. We begin by distributing on the left side 4 into the quantity x plus 6 to get 4x plus 24. And we carry down parts of the equation. And then we distribute the negative 5 into the quantity with the quantity x minus 9 to get minus 5x plus 45. We can still do more to simplify each side of the equation by combining our like terms. 4x plus 16 equals negative 5x plus 52. Once more, we see we have our two variable terms on opposite sides of our equation, 4x and negative 5x. I want to combine these like terms, but I must again use the addition property to do so. I'm going to choose to add 5x on both sides of the equation. Although note, you could, in theory, subtract 4x from both sides and still result in the same answer. Your steps will look slightly different than mine. Once I do that, I get 9x plus 16 equals 52. And I do my final two steps of isolating my variable term. 9x equals 36. And then isolating my variable by using the multiplication property. X equals 4. Therefore, 4 is my solution.